better way to demonstrate the workings of the digestive system.
I hope you don't mind that I'm eating. This is actually just my first course. For my birthday, the writers wrote me a script where I just get to eat the whole time.
And I can't think of a better way to demonstrate the workings of the digestive system.
Is actually pretty freaking disgusting. So maybe I shouldn't be eating right now.
And process nutrients.
Whatever.
Waiter!
We need to function.
Though, wait a second. If I remember correctly, digestion is actually pretty freaking disgusting. So maybe I shouldn't be eating right now.
The digestive system is so fundamental that it's basically step number one in the guide to how to make an animal. You probably remember that during the embryonic development of most animals, the digestive tract is the very first thing. The digestive system is so fundamental that it's basically step number one in the guide to how to make an animal. You probably remember that during the embryonic development of most animals, the digestive tract is and pretty much every animal has a digestive system. Some blastula, that little wad of cells that we all from it. In fact, digestive tracts are specially adapted to animals' feeding behavior and diet. For instance, a housefly eats, and pretty much every animal has a digestive system of granulated food, but they're not all before it does that, it's got a digestive tract especially adapted to animals' feeding behavior and diet. For instance, a housefly eats mostly liquid or very finely granulated food, but before it does that, it's got a most vertebrates put food in one end of the tube in our digestive system, processes it, and then for a while before it sucks it up the other end of the tube. No muss, no fuss. Well, actually, there's a little bit of muss at the end. Less common. Most vertebrates. But the beauty of it is that this whole process is run by our autonomic nervous system, so we don't it gets rid of the think about it until maybe the very last step. No muss, no fuss. Well, actually, there's a little bit of muss and a bran muffin. Then, but the beauty of it is that this whole process is run by our digestive tract, so we don't have to think about it until maybe the very last step when we're in traffic. For instance, dogs are mostly carnivores and also scavengers.
We have to think about it a
little bit. Mostly among vertebrates, sometimes the digestive tract for a while. So the dog's digestive system organs that do different things, absorb as many nutrients as possible, and for instance, dogs are mostly carnivores and also scavengers. Dogs have an extremely short digestive tract because dead for a while. So the dog's digestive system has better be able to digest, absorb as many nutrients as possible, and then bad bacteria somebody's lawn all in a period of about 6 hours. Dogs have an extremely short digestive tract because cows, on the other hand, take a very, very, very long time to digest their food, around 80 hours. The bad bacteria that they have to living on that armadillo carcass is going to take grass has a ton of cellulose in it, and evolution has cows, on the other hand, take a very, very, very long time to digest their food, around 80 hours. So cows have microorganisms in their guts that break down the cellulose for them. Grass has a ton of cellulose in it, and evolution has yet to produce an animal that can manufacture stomach acid and a lot of cud chewing. So cows have microorganisms in their guts that break down the cellulose for them. So nature is full of crazy digestion stories, and I honestly wish that I had time to tell them all. But let's focus on human digestion from now on, mostly because you're probably a human. So nature is full of crazy digestion stories, and I honestly wish that I had time to tell them all. And two, let's focus on human digestion from now on, mostly because you're probably a human. We eat plants and meat, and you'll be wanting to know how your body does all this stuff. Like most animals, humans have a bunch of different pretty good all-purpose in our digestive tracts that we're omnivores down to raw, we eat so that it can be absorbed and used by our bodies. Generalized. The secret to successful digestion, like most animals, maximizing a bunch of different acids in more than one way. The first way we maximize surface area is on the food itself. So let's say I take a bite out of this apple. By our bodies. The secret to successful digestion
like an
is
apple
maximizing
sitting there in my mouth.
In more than one way.
I got enzymes in my saliva that immediately start breaking it down. Like the outside of the boulder, is I swallowed this chunk whole right now. Not only will it hurt like an apple boulder.
The rest of my digestive system will have a really hard time dealing with it.
I got enzymes in my saliva that immediately start breaking it down. Like the outsides of the boulder, as I swallowed this chunk whole right now. Not only would it hurt like heck.
The rest of my digestive system would have a really hard time dealing with it because
double, triple, quadruple the surface area on the food. I'm making up apple gravel from the apple boulder. When I use my awesome
maybe even apple sand. For humans, chewing is key because breaking down our food into smaller and smaller bits allows enzymes and acids to get at them. And after
I'm making up apple gravel from the apple boulder.
The chemicals break them down further sand. For humans, chewing is key because breaking down our food into smaller and smaller bits allows enzymes and acids to get at them. But it's not just the surface area of the food that's important. The surface area of the digestive system is key to the whole process as well. Last time I talked about how we have a whole bunch of surface area in our lungs to absorb tons of oxygen. But it's not just the surface area of the food that's important. The surface area of the digestive system is key to the whole process as well. Last time I talked about how we have a whole bunch of surface area in our lungs to absorb tons of oxygen. Plus, inside inside our small digestive system works in much the same way. Most of the fibers with absorbing fibers on them, and no, I didn't speak. The fibers have fibers.
That's how hard our intestines work to increase their surface
Plus,
area.
last episode I was all impressed that lungs have a total surface area of 75 square meters. Fibers on small intestine,
and no, I didn't
has a
speak.
surface area. Fibers have fibers.
That's how hard our intestines work to increase their surface area.
Last episode I was all impressed that lungs have a total surface area of 75 square meters. But I'm getting ahead of myself here. Digestion does not start at the small intestine, people. It starts at the mouth. Now, as you can see, this hot pocket is surrounded by some kind of bread. Call it that, bread. But I'm getting ahead of myself here. Digestion does not start at the small intestine, people. It starts at the mouth. Now, as you can see, this hot pocket is surrounded by some kind of bread. Saliva, which call it that, bread is a starch which breaks down into glucose. The more I chew, the more amylase will get to all the different sides of the bread. And that's why the more you chew bread, the sweeter it tastes. Amylase doesn't really do much to the meat of the cheese in this thing. I've got other enzymes and acids that are going to work on them later on in the system. But I am going to chew all that stuff up real good right now so that those other enzymes can do their jobs later. Amylase doesn't really do much to the meat of the cheese in this thing. I've got other enzymes and acids that are going to work on them later on in the system. So now the masticated hot pocket is passed down my later on in the system. But I am going to chew all that stuff up real good right now so that those other enzymes can do their jobs later. I'm going to swallow trachea when I swallow. So now the masticated hot pocket is passed down my respiratory system. So this ball of food that I just swallowed actually has a scientific name. It's called a bolus. Cool flap rides a kind of wave of muscle action down the trachea when I swallow. This wave-like contraction up in my respiratory system. So this ball of food that I just swallowed actually has a scientific name. It's basically how most of the movement rides a kind of wave of muscle action down. Now my hot pocket bolus is this wave-like contraction, which is where the muscles really start getting esophagus. The stomach basically takes a scorched earth approach to digestion. It's not messing around. It's like a churning cement mixture that can contract and expand in my stomach now, which is where the food really starts getting manhandled. The stomach's job is to turn everything over and over, smushing and mixing all the pieces up with its cocktail of acids. It's like a churning cement mixture that can contract and expand made up of hydrochloric acid, an enzyme called pepsin, called Rugy. Your stomach's job is to turn everything over and over, smushing and mixing all the pieces up with its cocktail of acid. If you got it on your hand, it would give you a chemical burn. Gastric juice is mainly made up of hydrochloric acid, an enzyme called pepsin, and some mucus. And the pepsin, hydrochloric acid, has a pH of about 1. Now that mucus is important. It's there to protect your stomach so that it doesn't down and hopefully digest itself. When you don't have enough of that mucus, and the pepsin starts breaking down proteins into your stomach lining. Now that mucus is important. And the water's just in there to protect your stomach so that what you want by the time your food leaves your stomach. When you don't have enough of that mucus, you kind of liquidy slop that you might be familiar with from the last time you had a stomach virus. And the water's just in there to make everything all soupy because I didn't want to bring diarrhea into it too much because, you know, I've been eating. But when something bad is going on in your digestive tract, your body doesn't worry too much about absorbing nutrients. It just wants to get the chyme out of there. So chyme is what you see diarrhea into it too much because, you know, I've been eating. Anyway, there's a little valve or sphincter. Your body doesn't worry too much about absorbing nutrients. It just wants to get the chyme out of there. So chyme, the very beginning of the small intestine, is called the duodenum. This is where a lot of the small intestine action happens. There's a little valve or sphincter between the stomach and the small intestine that regulates secreted, like bicarbonate, which neutralizes the gastric acid. The very beginning of the small intestine, the coolness of the small duodenum. This is where a lot of the small intestine action happens, by which I mean lots of things get absorbed and also secreted. And again, bicarbonate, the reason it's so good at absorbing is because all of the surface area. Now the coolness of the small intestine, a lot of that surface area comes from the fact that despite its name, your small intestine is freaking long. And again, in a human, it can range anywhere from 4.5 to 10.5 meters. But that's not all. The whole inside is lined with the fact that despite its name, it has tons of ridges and folds in it. Surface area to the max. In a human, it can range anywhere from 4.5 to 10.5 meters. But that's not all. The whole inside is lined with epithelial tissue and has tons of ridges and folds in it. Each villus, which is only like half a millimeter long, is covered in tiny little microvilli, providing even more surface area. In fact, apparently, the small intestine has a texture kind of like each villus, which is only like half a millimeter long, is covered in teeny tiny little microvilli, providing even more surface. So another thing the small intestine does with the small intestine has a texture kind of like velvet, stuff like this milkshake. Near the top of your small intestine is a little pipe. Great, now I eat the milkshake. Fantastic. Okay, so another thing the small intestine does with the help of its friend the gallbladder is break down fatty stuff like dish detergent. Near the top of your small intestine is a little pipe where bile salts. It takes hydrophobic fat molecules stored by the gallbladder fatty acids and monoglycerides, which can be absorbed by all that epithelial tissue. Works like dish detergent on a pan you just fried something in. It's an emulsifier. It takes hydrophobic fat molecules and breaks them up into fatty acids. After your food passes through those yards and yards of small intestine, the chyme goes through another sphincter and enters the cecum, the
beginning of the large intestine.
The large intestine's job is to remove most of
After
the
your
water
food passes
and bile
through
salts
those
from
yards
the
and
chyme,
yards
so
of
you don't
small
have
intestine
constant
diarrhea,
The chyme
so
goes through
think
another
of
sphincter.
It's called
and
large
enters
because
because
it's
it's
wider
the
than the
beginning of the
small
large
intestine,
intestine.
but it's
The
not
large
nearly as
intestine's
long.
job
It's
is to
basically
remove
just
most
a
of the
1.5
water
meter
and bile
victory lap
salts from
around
the
the
chyme,
outside
so
of
you
the
don't
small
have
intestine.
constant diarrhea.
And it calls
So
it good.
also,
Think of that.
it's
It's
called
mentioned
large
at the end of the
because it's
cecum,
wider
there's a
than the
little
small
tube
intestine, but it's
where
not
the
nearly as
appendix
long. It's
comes in.
basically
For a long
just
time,
a
we thought that the
1.5
appendix
meter
was a
victory lap around the
worthless
outside of the
vestigial
small
structure
intestine,
that
and
we
then it
used
calls
to
it
need
good.
at some point in our
Also,
evolution,
should
but
mention
didn't
at
need
the
it
end of the
However,
cecum,
recent
there's a
studies
little
are finding that
tube
the purpose of the
where the
appendix in
appendix
modern humans
comes
is
in.
probably
For a long time, we
to
thought
act
that the
as a
appendix
safe house
was a
for all the good
worthless
bacteria
vestigial
you need to
structure
help you
that
digest
we
your
used to
food.
need at some point
If
in
you
our
get a virus
evolution,
or
but didn't
food
need
poisoning or
anymore. However,
something, and all
recent
your
studies are
digestive
finding that the
system
purpose
say,
of the
"Get
appendix
it
in
all
modern
out
humans
of
is
me."
probably
The appendix has a little
to act
sample
as
of your
safe
gut
house for
bacteria
all
that
the
it
good
spits out
bacteria
to help you
need to help you
recolonize
digest
after
your
your
food.
illness. So I think you're
If you get a
probably
virus
familiar
or
with the
food
final
poisoning
step
or something
in
in
the
all your
digestive
digestive
system.
system,
Say,
that's
get it all
the whole
out
thing.
of
Your
me.
food
The
can
appendix has a
spend
little
as
sample
long
of your
as
gut
3
bacteria
days
that
in
it
your
spits
digestive
out
tract,
to help you
and a lot of that
recolonize
time is
after
spent
your
in the large
illness.
intestine.
So I think you're probably
mostly
familiar with the
reabsorbing
final
the
step
excess
in
water
the
from
digestive
chyme
system.
and
That's
prepping your poo for
the
its
poo
great
thing.
entrance
Your food
into the
can
world.
spend as long
When
as
it's done,
3 days
it
in your
passes through
digestive
everybody's
tract,
favorite
and a lot of that
sphincters,
time is
the
spent in the
anal
large
sphincters.
intestine.
There are two of them,
Mostly
and you know,
reabsorbing the excess
out in the
water
world,
from the chyme
live
and
its own
prepping your
life.
poo
And that's
for its
the end
great
of our little
entrance into
tale
the
here
world.
that
Begins
when
with
it's
the
done,
Hot Pocket.
it passes through everybody's
I hope
favorite
you've done it
sphincters,
next
the
time.
anal
For more
sphincters. There are two of
disgustingness,
them.
as we discussed
And you know,
details
out in the world,
of the
to
excretory
live its
system.
own life.
Until then,
And that's the end of our
bon
little
appetit.
tale.